Now here we come to the theoretical part. If we have a ball and it's dropped from a zero initial velocity and it's accelerated by the gravitational acceleration g, now the vertical distance traveled by the ball h will be half times g times t square. And in our experiment we have two people measuring the time, and the first one is T1 standing on the second floor and the second one is T2 standing on the third floor, and the ball here just going up and down. Okay, now the first timer, he will start measuring the time when he sees the ball in front of his eye. So when the ball going up, he starts the stopwatch, and then he stop the stopwatch when the ball going down right in front of his eye. So that's T1. And let's assume that the distance travel from this position to the maximum position is h1. Okay, again T1 is here, so that's twice the time here. So be careful when we plugging this information into this formula. It will be h1 is equal to half times g times half T1 square. Now we will have that h1 is 1/8 g times T1 square. Now the same thing also applies for the T2. Here the time for T2, and assume that the vertical distance is h2, therefore h2 here is 1/8 times g times t2 square. Now if we subtract this, so we subtract the left and right side, we will have that h1 minus h2, this minus this, so it will just, this distance h equal to 1/8 times g times T1 square minus T2 square. So h is equal to now to find the g here, we'll get that g is equal to 8 times the distance between their eyes, h, divided by T1 square minus T2 square. So in this experiment, what we will need to have is also the information of the distance between the timer 1 and timer 2. If you want to get more accuracy, you will get the distance between their eyes. So this is the experiment, and you can try this at school if you have many students, and also this will be a very exciting activity. Good luck and thank you for watching. Now let's see our experiment.